Hello and welcome to the Chemistry Made Simple podcast. I'm your host Matthew Macario, and this is the podcast where you get chemistry confident and ready to go from point A to grade A. Hello, welcome back. How's your week gone and how has your chemistry studies been in that time? I hope it went well. In this episode, we're going to be talking about a family of organic compounds called alkenes. So we're going to talk about what is it that makes a compound an alkene. In other words, we're defining what an alkene is. We're going to mention their general formula. We're going to talk a little bit about their structure and shape. We'll also mention about their properties and their reactivity as well. So let's start with what is an alkene. An alkene is an organic compound, a hydrocarbon, has a double bond between two adjacent carbons. It's a hydrocarbon, meaning there's only carbon and hydrogen atoms in the compound. And alkenes are one of the unsaturated types of hydrocarbons, meaning that there's at least one double bond somewhere in the molecule. The general formula for an alkene is CnH2n, where N is the number of carbons present. When it comes to naming of alkenes, I've already talked about that in an episode called The Naming of Organic Compounds, and I'll put a link to that in the show notes. So if that's what you want to know, go and listen to that episode now. Okay, you're back. Excellent. The next thing is the structure and shape of alkenes. And let's first think about the simplest alkene. The simplest alkene is ethene with 2 carbons and 4 hydrogens. There's a double bond between the 2 carbons. And the shape of that molecule is pretty two-dimensional. It's planar, it's flat. So if we think about one of the carbons, it has equally spaced bonds that are 120 degrees separated from each other. So why does that stay flat? Why is it not able to twist around the carbon-to-carbon bond? Well, it's all to do with the makeup of that bond, that double bond between the 2 carbons. There is a sigma bond and a pi bond between those 2 carbons, and specifically the pi bond is preventing rotation around the axis of the bond. Let's think about what a pi bond is. Well, each of the 2 carbons in that bond has a p orbital with a single electron in it. That p orbital is perpendicular to the plane of the sigma bond. The electrons in those p orbitals on the 2 carbons overlap each other and bond with each other. Because there is that pi bond as well as the sigma bond, there is no possibility of twisting and rotating of that carbon-to-carbon double bond in an alkene. So how does that double bond affect the physical properties of an alkene? It doesn't particularly affect the main things we look at, things like melting point and boiling point. We see the same trends as we see with alkanes, in as much as the larger and heavier the molecule is, the higher will be those melting points and boiling points. We also see the steric hindrance effect of side chains, just like we did with alkane. And you can go back and listen to my more in-depth explanation on the episode specifically about alkanes. The double bond also does not affect the polarity of the molecule and therefore doesn't affect its solubility in water. They are insoluble in water. The double bond does, however, affect reactivity considerably compared to an alkane. Although the double bond in an alkene, the double bond between the 2 carbons, is a significantly stronger bond than the single bond between 2 carbons in an alkane, it is counterintuitively the focus of where the reactivity happens. And the main reactivity we consider is addition reactions with electrophiles and addition reactions with each other to make polymers. Alkenes also undergo oxidation or combustion reactions in very much the same way as alkanes do. We just don't tend to use alkenes because their reactivity is really useful in other ways. And alkenes are the feedstock, the raw material of so many reactions to produce other products, such as the polymers that we talked about, which are plastics such as polythene and polypropylene. We'll talk about the reactivity in more depth in future episodes in this series. That's all for this episode. If you have questions on this, please do feel free to get in touch with me. The best way is in Patreon. So when you're on the show's Patreon community site, send me a message there or respond to a post there and ask away about this or other episodes, and I'll be very happy to answer those. In case you're not signed up yet, you can do so on patreon.com/chemistry made simple and sign up for a very small monthly amount, which helps support the show's production costs. And I really appreciate that. Where else can you find me? Well, on Instagram, you'll find me at Chemistry Made Simple, and you can also email me. It's matthew@chemistrymadesimple.net. I do like to hear from you. I'd love to hear what your takeaways are from this episode. What did you get from it? And if you've got some of those, please do tell your friends about them so you get them listening too. So that's all for this episode. Thank you for your attention for these few minutes. I look forward to speaking to you again soon. Until then, do look after yourself, and goodbye. Before you go, I just wanted to let you know that we're going to be starting having accountability sessions in our Patreon community starting later this month. The idea is you come along to a weekly call, state what it is that you intend to study during the week, and then the following week's call, tell us how you did, with no shaming if you didn't achieve what you intended. And you also tell us what you're intending to do for the next week, and so on. This is going to be included free for CMS Plus members in the Chemistry Made Simple Patreon site. If you're not already a member, you can sign up for a very small monthly donation. Just go to patreon.com/chemistry made simple. You'll find all the instructions there about how to join the call. You don't need a camera on, don't need a microphone. You can interact by typing if you wish. It's there to help you be more intentional about what you intend to study and what you do manage to study. So without any more ado, I'll see you there.